Hello, in this video we're going to go over problem 22 from University of Maryland High School Math Competition, which is a competition that I run every October. A sequence a1, a2, and so on satisfies a1 equals 5 over 2, an plus 1 equals an squared minus 2 for all n greater than or equal to 1. Let m be the integer which is closest to a sub 2023. The last digit of m equals 0, 2, 4, 6, or 8. Okay, so the first thing that I do anytime I face a problem involving sequences is to evaluate the first few terms. So the first term is 5 halves. The second term is 5 halves squared minus 2. So that would be 25 over 4 minus 2. And that gives us 25 minus 8 over 4, which is 17 over 4. Okay, then take that one and square that and then subtract 2. So if we square 17, we get 289 divided by 16 minus 2. That gives me 289 minus 32 divided by 16. And we have 16 here, and this gives us 257. Okay, so now looking at the denominators, the pattern is very clear. 2, 4, 16, those are powers of 2. The numerator 5, 17, 257, the pattern is pretty clear when I see the 257. 257 is 256 plus 1. So a1 is 2 squared plus 1 over 2 to the power of first, which is 2 plus 1 over 2. a2 is 2 to the fourth, which is 16 plus 1 over 2 squared. So if you divide that, you get 2 squared plus 1 over 2 squared. a3, we have the denominator as 2 to the power of 4. 256 is 2 to the power of 8, and then plus 1. So this is 2 to the power of 4th plus 1 over 2 to the power of 4th. Okay, so if you think about this one, it becomes pretty clear what the pattern is. So if you look at this, an seems to be 2 to the power of, the exponents are also powers of 2, so it's 2 to the power of 2 to the power of n minus 1 plus 1 over 2 to the power of 2 to the power of n minus 1. If you look at these exponents, you have 1, 2, and 4. So those are in fact powers of 2. So let's check and see if that is in fact correct. a1 is 2 to the power of 2 to the power of 0 plus 1 over 2 to the power of 2 to the power of 0, which is 2 plus 1 over 2, 5 over 2. So that checks out with what we had. Now let's take an and square that and then subtract 2 to see what we get. So we'll have to take 2 to the power of 2 to the power of n minus 1 plus 1 over 2 to the power of 2 to the power of n minus 1, square that and then subtract 2. The first one squared gives you 2 to the power of 2 to the power of n. The second one squared gives you 1 over 2 to the power of 2 to the power of n, and then plus twice the product of the two numbers, 2 to the power of 2 to the power of n minus 1, and 1 over 2 to the power of 2 to the power of n minus 1, and then of course minus 2. So clearly these two cancel, and we get exactly the next term, which is 2 to the power of 2 to the power of n plus 1 over 2 to the power of 2 to the power of n. And this was a sub n plus 1, so that in fact matches what we found here. Okay, so what we got is that an is in fact 2 to the power of 2 to the power of n minus 1 plus 1 over 2 to the power of 2 to the power of n minus 1, which means the closest number to a 2023 is 2 to the power of 2 to the power of 2022. So the number that they gave us is in fact 2 to the power of 2 to the power of 2022. Now they ask us to find remainder of this when we divide it by 10. Clearly m, when you divide it by 2, is 0. M is even, so we'll have to look at m when we divide it by 5. Now if you look at powers of 2, 2 to the power of k mod 5, we get 2 and then 4 and then 8, which is 3 mod 5, and then 16, which is 1 mod 5. So 2 to the power of 4 is just 1 mod 5. What does that tell us? It tells us if I look at 2 to the power of 2 to the power of 2022, that is also 1 mod 5. So the number that I have is m is 1 mod 5, and it is 0 mod 2. So what number is it that it is 1 mod 5 and 0 mod 2, that is exactly 6 mod 10. So the last digit of that number is 6, which is the answer choice D.